Hello everyone, my name is Fatma Ahmed Abel, and today I will be solving a couple of questions from Applied Fluid Mechanics course. And the first question is from lecture 8, which is about energy balance. Now, as you can see in this question, number 10, it states that the water flows at a rate of 0.035 meter cube per second in a horizontal pipe hose, and the diameter is reduced from 15 centimeter to 8 centimeter by a reducer if the pressure at the center line is measured to be 480 kilopascal and 445 kilopascal before and after the reducer. Respectively, determine the irreversible head loss in the reducer and take the kinetic energy correction factor to be 1.05. So, before we start solving for this question, let's write the given values. So now we have the volume flow rate is equal to 0.035 meter cube per second, and the diameter 1 is equal to 15 centimeter. Diameter 2 is measured to be 8 centimeter, and P1 is equal to 480 kilopascal, and P2 is equal to 445 kilopascal, and the kinetic energy correction factor is equal to 1.05. So now, and we are required to find the head loss. So first of all, if you wanna find out the head loss, we have to find out the value of mass flow rate, and I will be use the formula of mass flow rate, which is density times the volume flow rate. So I will assume that the density is 1000 because it's not given. So I will plug it, and we have the value of the volume flow rate, and the mass flow rate will be equal to 35 kilogram per second. Now, since it's a pipe, we will use the formula of area, which is area equal to pi d square over 4. And first of all, we have to convert the values to meter. So we will multiply it by 10 to the power minus 2. And now I will convert them and find the value of area 1 and 2. And now I will use the the areas to find the velocity of 1 and velocity of 2. So I will be using the formula m dot divided by density times the area, and it will be area 1. And for the velocity 2, m dot divided by density times area 2. So I will be using the values to find the velocities. So and now I can find out the head loss from the energy balance equation, and we almost find out the all of unknowns that was required to find the head loss. So I will plug the equation of energy balance. So I will be cancelling the H turbine with the H pump because we are not required to find them, and the question didn't mention the pump or the turbine. And I will cancel out the Z1 and Z2 because they are almost equal to each other. So now I can write the equation according to the HL, and I will rewrite the equation now. Now I will plug the values that we have already, and some of them we did find it. So I will write the numbers. Before continuing the solving, I want to mention that I did multiply it by 10 to the power 3 because it's kilopascal, and kilo is 1,000, so it's time 10 to the power 3. So this is the value of the headless, which is equal to 1.18 meter. And now we solve the question.